Homogeneous differential equations are interesting. Basically, they say that a function of degree n is homogeneous if I can plug in tx, everywhere I have an x, and ty for everywhere I have a y, and I can get out t to some power n, that's my degree, times my original function. And it turns out that if you have a homogeneous differential equation of the form mxy dx plus nxy dy, you can solve this if they're homogeneous and of the same degree. Now let's just see if this is homogeneous or not. You remember what you want to do is you want to plug in tx and ty. So here is x, so this is going to be tx squared times ty minus 4 tx cubed plus 3 tx ty squared. Let's see what we get here. This is t squared x squared times ty minus 4 t cubed x cubed plus 3 tx t squared y squared. Now collecting all my t's here, this is t cubed x squared y minus, I'm going to put the t cubed out front here, 4x cubed plus t cubed, it's a plus, not a t, 3xy squared. Now I can factor t cubed out of each term. I'm left with x squared y minus 4x cubed plus 3xy squared. And it turns out, lo and behold, this is t cubed f of x, y. So this is indeed homogeneous, degree 3. Now let's look at this function right here. Let me plug in f of tx, ty. So this is going to be tx times e to the tx divided by ty plus ty sine tx, or ty, excuse me, divided by tx. And this simplifies to tx e to the x divided by y plus ty sine y over x. And lo and behold, this is t times x e to the x divided by y plus y sine. So indeed, this is homogeneous, degree 1. If we look at this equation, let's see if this one's homogeneous. F of tx, ty is, let's see, this is tx plus ty squared. So this is t times x plus t squared y squared. Now, there's no way, I don't have the same number of t's in each, so this is not homogeneous. Now, there are ways to look and quickly see if a function is homogeneous or not. Basically, you just need to look at the powers of x and y. This one right here has a power of 2, power of 2, power of 1. So do you think this one is homogeneous or not? And the answer is no. This one has a power of 3 and a power of 3, so this one will be homogeneous. While this one I've got power of 2 times the power of 0, so pretty much immediately this one's going to be not.